Quick one today. We are looking at two models of light by Newton and Huygens. Now, Newton thought that light was made of particles, and Huygens thought that light was made of waves. Now, they were both around at the same time. However, Newton's theory that light was made of particles called corpuscles um, was the main theory for 100 years. Um, Mostly because of Newton's prestige. His laws of motion were accepted as revolutionary. However, Huygens turned out to be correct. There were some things that light could do which could only be explained by their wave nature. But then, much later on, there was a bit of a twist to that as well when Einstein came around. So, what was the experimental evidence? That's what we're asked to look at here. Now, Newton saw waves like sound waves and water waves and saw that they didn't travel or thought that they didn't travel in straight lines. If you make a sound, that sound travels, fills a room and can go around bends and things like that. So he thought that light travels in straight lines and particles do not. Um, and he looked at the phenomena of reflection of a surface. Should put that to the side. He looked at that phenomena and said only something that travels in straight lines should be able to reflect. And he also looked at refraction. So when light goes into a surface and then bends, he thought that these things could only be possible by something that travels in straight lines like light, whereas a sound or a water wave couldn't do this. And it's true, things that are particles can reflect and refract to some extent. So, good for Newton, but he was wrong that thinking that it was something that only particles could do. Waves can do both of those things as well. Now, there were a few things that particles can't do, and they worked against Newton. One is interference. If you've got uh, a wave stacked on top of another wave, they add together to create an even larger wave. This is something that particle theory cannot do, while the wave theory can. There is also diffraction. This is when you have waves that um, hit a boundary. The waves come, they hit a boundary, and then they spread out anew from that boundary. This is something that particles do not do, and waves do. And really, it was a combination of these two things in Young's double slit experiment in the previous video. That was what really proved that light is a wave. That double slit experiment used diffraction plus interference to get a pattern which could not be explained by particles at all. Now, I said there was a twist. The twist is the photoelectric effect, and I guess to some extent black body radiation. The photoelectric effect was an effect where light is absorbed as a particle and is not as a continuous wave, and this is what this marked the beginning of quantum mechanics. So as soon as we bring quantum physics into the equation, light can act as a particle. In reality, or where we're at now in physics at least anyway, light is actually a combination of both particle and wave, or really it's kind of neither. It's kind of some object that has some particle properties and some wave properties. But we will see more of that when we get to the next section on quantum physics. For now, this is all the evidence that supports these two models of light.